My intended deliverable is a simulation-based curriculum for IB Math SL. Now one might be tempted to ask, why is this even necessary? In order to answer that, let's have a look at the stats. I'm currently a teacher of Math SL and have been so for about 6 years. This chart shows actual data on the performance of students at the school where I now teach. The Math SL course is assessed in the form of 3 components: the non-calculator component, the calculator required component, and the mathematical exploration. The mathematical exploration is a mathematically based project wherein students can explore any topic of their choosing. Unfortunately, year after year, students perform significantly lower on the mathematical exploration than they do in any other component. Now, any concerned educator will begin to wonder what the problem is. But I submit to you that a part of the problem is that there are few actual problems embedded in the written curriculum. That is, students have very few opportunities to solve actual real-world problems and, as a result, find the task of conducting an exploration very difficult. For example, this is a sample of what a typical textbook question might look like. As you can see, it is highly abstract and not actually solving a problem. A question like this, on the other hand, is asking the very same thing of the student, but within the context of an actual problem. Now that we've explored what the problem is and what the cause might be, how do we address it? Well, I propose that we go back to our mathematical roots.
Human beings, from our earliest beginnings, have searched for solutions to basic problems: building homes, measuring space, keeping track of seasons, and counting objects. Over 30,000 years ago, early Paleolithic people kept track of the passing seasons and the changes of weather for planting. To represent the passing of time, they carved tally marks on cave walls or slashed tallies on bones, wood, or stone. Each tally stood for 1. But this system was awkward when it came to large amounts, so symbols were eventually created that stood for groups of objects. Sumerian clay stones have been found that date to the 4th millennium BC. A small clay cone was used for 1. A clay ball was used for 10.
The caveman mathematician had no textbooks, he had no worksheets. All he wanted to do was to understand the world around him. My intended deliverable will be a curriculum that contains a series of simulations of real-world phenomena. This simulation demonstrates the growth of a rabbit population over time and can be used as a study of the concept of exponential functions or even logistic functions. Many curricula that use simulations often use applets such as this. This is not what I'm intending to do. I perceive this as merely digitizing the typical textbook rather than having students observe real-world phenomena. Dr. Roos, for example, in 2010, published a book called Teaching and Learning Mathematics Using Simulation. Although this was a novel idea, I believe that the simulations are primarily applets of graphs and were often divorced from the real-world context. I do realize that a simulation is only as instructive as the curriculum that supports it. I therefore propose a supporting written curriculum that fosters ART, A-R-T. That is, The curriculum should foster active learning, wherein students are allowed to exercise their higher order thinking skills. The curriculum should facilitate reflection and specifically metacognition. And importantly, the curriculum should facilitate students transferring observations made of real-world simulations to more abstract and general scenarios.